Hi, my name is Julieta Trejo, and I am a graduate student in the Department of Psychology. My mentor is Dr. Yuan Bo Peng. Today, I'm going to be sharing my research titled Antinociception Induced by High-Intensity Electrical Brain Stimulation. The implementation of electroconvulsive therapy, also known as ECT, has been used for many decades, more specifically in many depressive patients who have revealed resistance to other modes of treatment. In the present study, we are testing to see if ECT proves to be effective in the relief of pain through the use of continuous local field potential, also known as LFP. So moving into the methodology of this study, this is an ongoing study, therefore we have used 6 adult male Sprague dolly rats thus far and implanted electrodes in 4 areas of the brain: the right anterior cingulate cortex, also known as the ACC, the right and the left amygdala. You'll see this as RAMG and LAMG, and the right ventral tegmental area, also known as the VTA. For the formalin model induction, the LFP signal was recorded under 3% isoflurane anesthesia for 10 minutes as baseline in all 3 conditions. Then formalin was injected after the 10-minute baseline recording in the control condition of 2 rats and also in the experimental condition of formalin followed by ECT administration in 3 rats. In the third condition of ECT administration followed by formalin in 1 rat, formalin was injected after ECT administration and continued the recording for 60 minutes post-injection. Now for the ECT model induction, in the 2 experimental conditions, the ECT parameters consisted of 3 stimulations delivered at a pulse frequency of 50 pulses per second with a pulse width of 0.7 milliseconds, the pulse intensity at 5 milliamp for a total duration of 2 seconds. We then did a 10-minute recording followed by another set of 3 stimulations with these same parameters, but this time at a milliamp of 20 instead of 5, and recorded again for 10 minutes. Finally, we delivered the last set of stimulations, cranking the milliamp up to 50. These shocks were delivered 10 to 15 seconds apart. Now, moving on to the results section, we're going to first start down here. This is just my preliminary data. This is just showing the raw data of a full formalin response. So I don't know if you can see this. Let me try to zoom in. So here at, we did a 6-minute baseline and then we injected formalin, and you could see the increase of activity happening here. This is the ACC region in 1 rat. And now we see the same formalin response continuing, but we are introducing the ECT stimulations. So the first stimulation was delivered at 1 milliamp for 1 second, and then we did 5 milliamp for 1 second, and finally 5 milliamp for 3 seconds. And whenever you compare this ECT effect to this formalin effect, you see a clear inhibition happening or a suppression of power. Next, we did another simulation at 10 milliamp 3 seconds, and then we continued recording. And then finally, we disconnected the module and we cranked up the stimulation to 50 milliamp 2 seconds, and we did this 3 times. The reason we disconnect the module is that we don't want any damage happening from these strong stimulations. And then finally, we reconnect the module. And you can see here a clear inhibition happening when we compare this side to the pure formalin side. You see that this side is a lot more quiet. Now moving up here, this is just the power spectrum analysis. This section shows 10 seconds data, whereas this section shows 5 minutes data. And this section here is just pure formalin, whereas this section is formalin followed by ECT. And you see an increase of activity happening here, but whenever we introduce ECT, you see a suppression happening. And same on this side, this is pure formalin, and then this is the formalin followed by ECT. The findings for this study reveal that there is a brief suppression of LFP power post-ECT administration in the 4 designated brain regions. This brief suppression indicates a possible analgesic effect that the ECT has on the brain. In the ECT followed by formalin condition, which the data was not shown here, the brief inhibition of formalin-induced activity was not as salient as the formalin followed by ECT condition, leading to the conclusion that administering ECT after a pain-inducing event may be the most effective. This is an ongoing study, as we will further explore this analgesic effect in anesthetized animals and its parameters.